In our final lesson of energy, we're going to learn how to calculate heat for phase changes. Okay, and specifically in these questions, we're going to be dealing with water, because for the regions, those values are listed for you on table B. So there are two different formulas of a phase change, because there really are only two types of phase change for regions level. And this is when we're talking about changing from a solid to a liquid, or vice versa, going backwards from a liquid to a solid. Both of these qualify as a calculation for heat of fusion. Okay, so we use this when we're melting, we use this when we're freezing. And it's a simple version of what we were just doing, where Q is heat, M is mass, and HF is the heat of fusion, right? The heat of fusion is HF. For water, this value is listed on our reference table, on table B. For water, is 334 joules per gram. And that's it. I mean, that's the straightforward equation. The big thing here is that temperature is never changing. We talked about this in a few videos back. At a phase change, temperature is constant, which is why you don't find any information about temperature in this equation. Doesn't matter what temperature melts at, and it certainly does not change temperature. So let's take a look. Right? How much heat energy is absorbed when 10 grams of ice melts to form liquid water? So we're melting. And when we're melting, the only way we can calculate heat is by using the heat of fusion formula. So this is what we just talked about. Q equals MHF. And we plug and go. Now we're looking for how much heat energy. So we're looking for Q. What I know is that I have 10 grams. HF for water is on the reference table. That value is a set value. Anytime water is freezing or ice is melting, it always requires 334 joules per gram. And so if we have 10 grams, we're simply going to be doing 10 times 334. And for this, Q would be equal to 3,340 joules. Awesome. Heat of vaporization is the same type of formula where it's just heat, mass, and a value. But the only difference here is we're doing the phase change of vaporization. So when we're turning a liquid into a gas. But just like the heat of fusion, that value and that formula is the same when we go the other way. So anytime we're dealing with a liquid to gas or gas to liquid, boiling or condensing, we're going to be using this formula. So let's put it to use. Q equals MHV. Q, how much heat? Q. How much heat is absorbed when 70 grams of water is completely vaporized, meaning liquid to gas, at its boiling point? Again, there's no temperature listed in here. And even if there was, like let's just say this said at 100 degrees Celsius. This number never factors into this formula because it doesn't matter what the temperature is at a phase change. It's a constant value. So we can ignore a temperature. We can ignore at its boiling point. We know that this is the heat of vaporization. So my Q is equal to 70 grams. Now this is a different number. HV, also found on the reference table, HV on table B for H2O is 2,260 joules per gram. So we're going to be taking our 70 grams and multiplying that by 2,260. Punch that into a calculator. 70 times 2,260. We find out that it requires 158,200 joules of energy in order to boil 70 grams of water. And those two formulas are the two formulas to use during a phase change. The hardest part of these, the three heat formulas, Q equals MC delta T, Q equals MHF, Q equals MHV. The hardest part is figuring out which one to use. And that's honestly not that difficult, but that should be the most difficult part of these questions. So I wish you luck. That concludes this unit of energy. I hope it was helpful. Please like the videos, subscribe to my channel, and we'll check you out in the next unit.